It's a pleasure to have you here. I'm quite excited about this session. Uh, Actually, the whole world is now facing a very challenging time while we cannot go to the field as an agronomist or as a farmers. We cannot go everywhere and just to collect data as we used to do. So we built this session in order just to direct us to another options and another alternatives that enabling us to control the plots more or less from far away. So we called this lecture Remote Crop Optimization in Challenging Times. But actually, the challenging times that just make it um, um, uh, more understandable why it is important, but also for a very regular time, the tools that I'm going to demonstrate over here are usable as well. And usually they will help you to get better, at least better monitoring. And in most of the cases, I'm quite sure that you can make the yield and the quality increase. And also when we are talking about investments in agriculture or inputs or all of our aspects of irrigation and fertilization and so on, all of them you can save some expense. Now I will talk a little bit about myself just for you to know me a little bit. Um, so as Yuval mentioned, my name is Gilad. I'm an agronomist. For the last 20 years, I'm working as an extension advisor or consultant, if you wish, for agriculture. I started my career in the Ministry of Agriculture in Israel. Israel has a public system for extension service for the growers. Over there, I specialized mostly in two aspects. One of them was irrigation and fertilization, and the other one was crop optimization and growing, especially on vegetables. Now, when I started to work with a lot of farmers, I saw and I realized several things that actually they made, they just started a very, I think, very a specific idea of my own, how monitoring and how tools in order to promote agriculture or collecting data and then promoting agriculture can be usable and can make the whole extension services or even just private consulting, they can be more precise and more contribute to the growers. Uh, Actually, in the last few years, I'm working with a lot of digitation in the fields, um, and it sometimes can be really confusing because there are many options today in the market. Many countries, in many firms and many companies in several countries developing a lot of tools. Sometimes the tools are very smart, sometimes the idea looks terrific, but I think it will be difficult to adjust for the grower, for a particular grower. So I think what is missing is just taking the data from the field and then analyze it and then decide just how to make out of it and action items, which will be very specific and very precise and very understandable for the grower. So first of all, let's just talk about how is agricultural advice or how is agronomist advice or consultancy usually works. Usually the agronomist will meet maybe some other agronomist and the growers, and then we have a nice tour in the field. We're just getting our impression. Sometimes we are asking the grower some things. We're asking about his behavior, how he's acting by the aspect of irrigation, fertilization. We can just dig for climate conditions that had been in the field in the several several times or days or weeks before we arrive. And then after it, we just analyze it and decide what to do until the next time we are meeting. Now, for me, it's nice. This is a very nice method, but it's not perfect. And one of the main things that it make it not perfect is, first of all, in most of the cases, nothing remain for the grower for next seasons, or at least sometimes I can get an impression that one field that I'm visiting at looks like one thing, and the neighbor looks completely different, and not always I can just detect what the difference is. Okay, so this is very traditional. It's I think it has place, and it will be, I think, in the near future, maybe in the far future, we will have more of it, because sometimes this is the best option that we have. It's cheaper, sometimes it's not, and also it's for our human behavior, it's suitable. We all have this meeting and conversation and dialogue. That's obvious. But now let's think about what's happening in times like now. We cannot meet with the persons in the field. We cannot transfer everywhere as we wish. So that means that our consultant or our action items will be damaged. And I remember that when I started my career, I met with many agronomists that were much older than me, and they were excellent, and they were very qualified. And there was a tale that they used to tell, which is, there is nothing like visiting and touch the crop with your own hands. And for myself, I was thinking, well, maybe it's very good, and maybe it's really understandable why they think it's good. But for me, it was like with a question mark at the end. I thought to myself, maybe there is another option that even better from just arriving to the plot, talk to the grower, and get my impression. And some of the things that I notice on myself, yeah, it's that when I'm visiting the plot, if I'm visiting several plots, so the first one will affect the second meeting that I will have. For example, if in the first crop, the first field that I'm going to visit today, I will face a severe problem of, let's say, manganese deficiency. So my focus was on deficiency symptoms, and during the whole day, in other 10 plots that I'm going to visit, I will search and I will be very focused on deficiency symptoms, which is not necessarily should be the first priority for all the plots. Okay, so if we are just writing mainly what we are doing when we need to detect or to decide about action items. So first of all, we are collecting data all from the grower or from the sensors. We just have all this data, we get the impression from the plant, and then we have diagnose in the field of the physiology stage of the plot, how it looks like, what is its conditions, how the plant health looks like. Is it healthy? Is it, do we have diseases? Do we have insects? Do we have any other something that can affect the action items? And then we have like action items that we are leading the grower to do. We are challenging him, sometimes with a lot of questions, or give him some options. But in the bottom line, usually we will have treatments that we are going to offer, and also we are going to have instruction. They need to be very clear to the grower. Sometimes when we are asking the grower a question, did you really understand? He will say yes, but if we are going to talk about the real numbers, so we see that it's not really understandable, so we need to give the instructions in a very clear and very precise way. So if I will take all the things that we are doing in the field, so we will see it looks like a very long procedure, but actually it's quite simple. I would ask like this: what allows us to process information in order to give routine guidance for the growers or for the farmers? And this is in regular times. I'm not meaning now from far away. So usually it will be something like this. We have data, like I mentioned, collecting the data, and then we will have the gap, what we think that the plot should look like compared to what we are really facing to. I will give an examples later on. Sometimes it's a very simple parameters, and sometimes they are more complicated. Then we are going to detect the causes. We need to diagnose in the cause of the problem. What caused to the problem that we detect? Which problem is like the gap? Okay, sometimes it's a positive one, but sometimes it's negative. And then we will start to think on a solution. Just a second, I will add this one. Okay, and then we will think about the solution that we want to offer to the grower. This is based on a prior knowledge that we collected with our own experience and the adapted solution that we know that they are common. And then we will have the guidance. We will explain the grower exactly what is the solution, how to do that, how to apply. And then the next stage will be follow-up. Now, if we are thinking about it very generally, it looks like this is something that have to combine data analysis and also communication with the grower. And in this session, I want to talk a little bit about these two aspects, because sometimes, like the old agronomist told me, there is nothing like visiting the plots, but sometimes we cannot do that. And sometimes it's not really the best solution as well. Sometimes we have even a better solution, and I want to show you and to demonstrate some of them. Okay, so the first challenge, which looks like the main topic, it will be the data. How we are collecting data to obtain information from the farmer or from the plot. Okay, so this sounds like something that is really difficult to do from far away. But actually, and before that, I want to also to ask you to think about if you know why. First of all, why do we need to have monitoring? Why is it important? So the first thing, we want to react to the plant needs by the aspect of quantity, the timing, and the quality. For example, if we want, let's talk just about a simple method like irrigation or temperature, okay? Temperature, it's even more trivial. So first of all, we want to know if the temperature are suitable. We want to know the timing of the temperature, if the temperature that we are facing right now are suitable for the plant stage. And then we want to manage the crop. Sometimes, in some cases, in a lot of crops actually, usually we want to have stress management. I will give you an example. If we are talking about a crop like pepper, so pepper crop, at the first stage, we want just a good establishment. We want the plant to increase his vegetation. We want it to be developed. We want the roots to become deeper. We want an efficient system for water transferring and so on. We want to make sure that the photosynthesis is quite okay. But then sometimes we need to force the plant when the pepper plant starts to increase its vegetative ability. We will find it very difficult to stop this vegetative stage and just to convert it into a productive stage. We want to force the plant to flower, to blossom, flower, and then to have the fruit sets. Okay, so of course it's related to the temperature, but also it's related to the fertilization. Sometimes when we want to force the plant, which is very vegetative right now, we want it to switch into a productive stage, start to flower. So sometimes we need to make it a little bit suffer. What I mean is like we need to have stressful conditions just for several time in order to prevent the plant to just focus on vegetative. And then what we are doing is several things. First of all, it can be we are increase the radiation. If we are growing in a greenhouse, during the time that it's very vegetative, we want to stop the vegetative stage. We want to encourage the flowering. So we need to increase the radiation, the power radiation inside the greenhouse. So the method for this can be very, very easy. We can measure the power radiation inside the greenhouse, and then we want to increase it. Sometimes we can just go on the roof and just wash the roof if we are talking about greenhouses. Sometimes it can be covered with dust. Usually we are using a shade net, so we can remove the shade nets. This is a very simple example. Another example can be with fertilization. Sometimes when the plant is very healthy and very good, he will also start to, in a tomato or in cucumber. Actually, in cucumber, it's also very famous that if you want to have a high yield, so don't or try to avoid from too much fertilization. So in this case, if we want to manage the stress in order to start to produce cucumbers, or we see that our plot, our yield is quite low, and you have consultant with agronomists that will tell you that this is something that rely to connect to too much fertilization. So we can monitor the leaves, we can monitor the soil, and then we can just reduce the fertilization for the plot in order to achieve stress, to get stress or stressful conditions just for a period of time. So these are some examples for what is the reason that we need to monitor and what are the benefits. Another two trivial reasons for monitoring is to save waste of energy and money, of course, because if we are not monitoring, so usually we will add too much of everything, too much of irrigation, too much of fertilization, too much of plant protection materials. But if you are monitoring, you can be sure that you just added whatever it really needs and not in an additional quantities. From the other hand, if we are giving too less, so it's also a waste of money, because if the plant face a shortage of something, of any element, that means that we wouldn't get to the maximal yield that we can achieve. Okay, so in this case, it's also a saving of money just to get the maximal yield from the plot. The last aspect that that important for monitoring is the environmental values. We don't want to waste too much water. We don't want to inject too much fertilizers. That means that it's really relevant to monitor if we want to make sure that we are doing our job as person that works in agriculture. We need to make it in a responsible way. So if we are looking just on a very regular plot, this is like the example that I mentioned earlier. We are talking about a very beautiful plot of pepper. This picture was photoed in the Arava area in the desert of Israel. This is a pepper plot, and you see that there are no real monitoring tools over here, but this is something that I want to just make a spotlight on. First of all, we need to monitor the radiation. Radiation, sometimes it's really the most important aspect that the grower doesn't make, they don't put so much attention, and they should actually. So the two aspects that are relevant usually is, first of all, the power radiation itself. We know what the values per each plant. For example, for pepper, The maximal value of power radiation should be between 800 to 1,200 micro-Einstein per meter. That need to be on the peak. The other important aspect is how many hours in every day we have for photosynthesis. This is also very important because sometimes the day are very short and the radiation is low. So that means that in the short period of light hours, we need to increase the power radiation that penetrate into the greenhouse. The other aspect that we can monitor from far away, and this is very relevant for us right now, if we will have a detection about the power radiation from far away, and the grower will just report us what are these values, we already know some very important aspect for the plant. Another aspect will be the temperature and the relative humidity that have measured in the structure or in the building. This is very much relevant for most of the crops. I will give you an example on pepper. For example, if the grower will call you from far away, from distance, and he will tell you that I don't find enough flowers on the plant, so I don't have pollination, so I won't have yield. So the first thing you can detect from far away, first of all, are the temperatures and the relative humidity are suitable for flowering? Is it too cold? Is it too hot for flowering? Another question that can be asked is about the power radiation. Is the power radiation is good enough? Is it too low? Maybe very short day or short day and low value of radiation penetrate into the greenhouse, so therefore all the flowers are going to fall down. And this is something that we can just answer from far away. If the farmer has the data, he just can give us the data and we can advise exactly what is the problem and what he can do. Sometimes in the case of temperature and relative humidity, in a given condition of a greenhouse, we cannot do almost nothing, but sometimes we can. Okay, and sometimes we can do another agro techniques. If we have a given low power radiation inside the greenhouse, sometimes we can just remove some leaves or just remove one stem per plant in order to make the light that we already have to penetrate into the plant or into the canopy and increase the radiation that the plant facing to. Another aspect is the plant itself, about its health, about its physiology, about its production. If we have it on numbers, and I will show you it immediately on graphs, if you have a system of how to detect all these parameters, you will have a very powerful tool in order to have one look on a graph and to tell immediately if this plot is okay or not. Another monitoring aspect is about the soil, about irrigation. It includes, first of all, the given irrigation and also the conditions in the soil. Is the soil too tense, too dry? Is the soil too wet? Sometimes we have just a very shallow irrigation that's going to limit the uptake of the plant. So these are some things that it sounds like it's very difficult to detect from far away, but actually it's not. If the grower have some very simple tools, we can detect it from far away, and to give a lot of good answers from far away, from our laptop, we can just, or even from our cell phone, we can enter into the softwares and to see the condition and just to give a good advice from far away. Another aspect is the nutrition and the salinity. If we have a tool, and I will show you it immediately, very simple tools that the grower will be guided by you, or the grower will prepare it by himself. He can just take water or water solution from the soil to analyze it in a very simple, sometimes they are very cheap tools, and then give you the numbers that he figured out, and then you will have a lot of information about the condition of the plant. So monitoring, if we're talking about data, so first of all, I mentioned the environmental conditions. Usually it will be related to radiation. So we have this simple tool for measuring PAR radiation. The grower can measure the PAR every hour in a particular day or several times a day if you are suspecting that there is a problem, or just have simple monitoring of once a day, enter into the greenhouse, measuring the radiation, the PAR radiation inside the greenhouse compared to outside, write the percentage, and then we will know what are the conditions in the greenhouse. Another tools, very simple tools, is about temperature and humidity. So today we have a lot of kits like this that you can find in eBay or in Amazon, just to get some information with a data logger that measuring the pattern of temperature and relative humidity from the surrounding. And then you can get it or with your cell phone with a simple app, or by a SIM connection to the internet, and then you can have it from far away. If they don't have this option, the growers, so also it's relevant to use these simple and old-fashioned tools. This thermometer, simple thermometer, can enabling us to know what is the highest temperature that collected in the site, what was the minimal. Sometimes you can just get this information from the grower in order to understand if the plants suffer good conditions or not. This is a relative humidity measurement. It's also cost something like $20 US in the website. You can search. There are many options and many designs like this. A lot of sensors, and this is a sensor that combine relative humidity and temperature inside the greenhouse, and it's connected to the internet. And this is with a very simple software. You can see the pattern. Eventually, we would like to have something like this. This is just the temperature, for example. So over here, there is every 20 minutes, we have temperature measurement inside the grower, inside the greenhouse. And in this case, I brought this example because you see that the minimal temperature over here in every day, every parabola is 1 day, of course. This is the maximal temperature, which looks quite hot. It looks quite hot. It's above something like 26. But look at the minimal one. You see that it's 11. Now, for most of the varieties of pepper, if we have 5 or 6 days or 6 nights in a row that the minimal temperature for long period, more than 5 hours a night, is below 14 Celsius degrees, that means that the pollination will be defective. Okay, so this is something that helps us to monitor. We can see in what, this is the 14 temperature. We can measure the time from here to here and understand that these nights are not suitable for pollination. So don't try to force pollination because it wouldn't help. Okay, so this is a very simple advice for how to monitor from far away. Now let's go to the soil aspect, which looks more even more complicated. So yes, it's complicated to be in the soil of the grower in the several plots, but there are simple devices that you can also buy, or the grower buy from far away. This is one very simple kit. It costs approximately $50 US, 50 euro, something like this. You can buy it online. It's made of, it calls soil extractor pump. Over here, there is a ceramic cup and a tube. And over here, there is a valve. So what we are doing is right after irrigation, we are waiting for something like 20 to 30 minutes after the end of irrigation, when in the soil, everything becomes balanced. And then we can just pump to just do a vacuum inside to lock the vacuum with this valve for 1 or 2 or 3 hours. It depends on the soil type, and then come and open the valve and collect this water. And then on this water, we can do some analyze like pH of the solution, and then react upon it. If the pH is too high, sometimes we can inject more acid fertilizers, or just inject acid if we are talking about light soil. we can monitor the EC, or sometimes there are some simple tools of pH if someone don't want to buy this pH meter, which is more sophisticated and accurate. There are kits that cost almost nothing. You can buy it online as well. You just dip it in the solution and then you will get the pH of the solution. Another kit that's really easy to monitor is about the chloride. Sometimes in a place that they are arid area, like in Israel, for example, we have, or in other places that we have, or salinity, high salinity of the soil, or high salinity of the water source. We want to monitor and to see if we need to have leaching irrigations, just to leach the extra salts from the root zone. So what we will do, we will use this extractor, soils extractor pump, and then we are going to have a simple kit of titration and to measure how much chloride, how many ppms of chloride we have in the solution. If it's above 500, so we usually in most of the crops, we will advise the grower from far away. He can do it by himself. Just report the number, and then you can decide together if we need to do a leaching or not. Another element that we can measure over there, and it's very cheap as well, it's nitrogen. Nitrogen is one of the main elements, essential elements in fertilizer. So we have a kit that you can buy also everywhere if you don't have a store nearby for agricultural devices. So you can buy it online as well. This is just a simple kit that you are digging this stick in the solution. It changes its color from white to purple, and then you have on the bottle a scale, and you can see if it's suitable for which number, and then you will have how many ppm of nitrate do we have in the soil solution. Then you can just make the fertilizer adjustable to the plant needs. There are more sophisticated kits for the field, like this one. This is from a Japanese company that named Horiba. They have, for several elements, they have kits, which is a very small spectrophotometer. You just put few drops inside this part of this device, and then you will get a result in ppm, how many ppms of nitrate you have in this soil solution. Also, you have the pH, and they have for potassium and for calcium, and for EC, like electrical conductivity. And that's more or less the most important elements that we need to detect. Another important thing that you can detect with the same device is petioles nutrition. We just collect the petioles in the morning time before the plant started to transpirate. You're just taking some petioles from a diagnostic leaf. It needs to be top leaf, but not the newest one. It needs to be large enough, but not old. And then you need to just use this garlic smasher. You can just smash the solution of the petioles into this device. And if you are doing it like in a continuously way, like every other day or once a week, once in 3 days, you have a graph, you have a scale, and then you can see if the plant increase its value or decrease. And you know if you need to increase the fertilization or decrease. The method is very, very simple. It looks sophisticated, but actually it's not. This is the soil extractor pump. This is the injector that you can do the vacuum with. And then when you have the solution, this is the kits. Over here, I use it for nitrogen, potassium, and calcium. This is what I'm doing by myself in order to help the grower, but the grower can do it by himself. And then I have a graph, a scale, to detect what was in the previous measurement and what I have right now. And then I can decide if I want to reduce the fertilizer or increase it. Another tools which is very important for crop optimization from far away is the tensiometer. My purpose of putting this old photos is to show you this is a very, very old tool. This is a tool that invented like 120 years ago. It's very simple. It's just an empty tube that we are filling with water. Over here, we have a ceramic cup. We dig it to the soil and we place it like this. It's clogged to the atmosphere. So that means that if the plant going to transpirate water, the tension in the soil, some small quantity of the water from inside the tensiometer will go outside. The tension inside the tensiometer will be sensed, and then we will have increase of tension inside the soil. Today, of course, we are not working anymore with this kind of device. The tensiometer, the tube itself, remain more or less the same, but we are transferring the data every 2-3 minutes to a cloud. We have many companies that supply these devices, a lot of options. It doesn't cost a lot. It's not cheap as well. I think the cheapest one in Israel, it's something like 1,000 US dollars, but then it's remained for 10 years. So you can use it for many times, and it's very simple. It looks more or less like this, okay? Everything is with electricity. Beside tensiometer, when we're talking about soil moisture or how wet is the soil, besides this option, we have another soil sensors that are relevant as well. This is, for example, is from a company that calls Decagon. It's an American company. This, you see that it has 3 teeth. One of them is for the temperature of the soil, the other is for the salinity of the soil, and the third one is for the wetness, how wet it is. This is another device that just measuring how dry is the soil. And also there is the data logger and the SIM card that you can transfer the data into the internet. This is another device that really similar to here. Also, it's measuring temperature of the soil, salinity of the soil, and the moisture of the soil. After we have that, today you can just take it, if you have a big field, you can just have like a net. You can just put a lot of sensor all over and to just have it with the cloud to one main dashboard. In the field, it will look like this. Okay, these are the tensiometer. This is the box for transferring the data. This is actually a cellular unit. And then we will have graph like this. When the tension reduces, that means irrigation. And over here, we have 2 depths. One of them is 15 centimeters below surface. This is 30 centimeter below surface. And then we can see this is a very good example that we gave big irrigation, but a lot of water also went below the 30 centimeters of the root zone. So that means it's a little bit waste of water. Over here, there is another example that over here we irrigated. So you see that the tension reduces. And this is something that the grower apply and I do from far away. I'm looking in the internet, I'm looking in the graph, and I can tell him in this day, you see that over here, this is large irrigation. It's too much because you see that most of the water also passed the 30 centimeters. That means that the irrigation was too long. So the day after, he's irrigating smaller quantity, and just small quantity goes to the below the surface. Okay, so another thing that we can help the grower to monitor from far away is with a lab test, soil analysis. We can just tell the grower to have results from the laboratory, and then we can analyze it and to just let the grower tell the grower the information for how much.
גלעד? זה בכל המרכז. הנה, חזר.
This is from far away. I can tell the grower it happens too soon. It's in 11 o'clock, So in 11, give a very small quantity of additional irrigation because I don't want this shrinkage to happen. And if it happens, I don't want it to be so long. Over here, you see that from 11 o'clock until the evening, it just shrink. It didn't grow. The plant didn't grow. Okay, so over here we can detect in what time it happens and when is the right time for irrigation. Another use for dendrometer, we can just determine what is the fruit size. So from far away, I can know what is the fruit size, how much is its growth, in what rate is its growth, is it grow faster than other plots or slower than other plots. These are several elements that can be very useful and very helpful. Another thing that now I want to focus in a very, very simple data collection that we can just tell the grower to do from far away. You know that if the grower will measure, this is an example from real life, from my daily work for a plot of rosemary. I want to know when I want to estimate when they are going to be ready for harvesting. So they can just take a photo from far away with a scale, and I can just decide what is its height compared to previous week. And then I can just know the pattern, how fast it grows. And I can know, like 2 weeks before harvesting, I can give an alert to the grower, prepare yourself for harvesting. Also, I can use it for color index. I can decide from far away if it's green enough. Another photo that demonstrates in the density, I want to detect the vegetation. So over here, I have a scale, and I can count how many stems do I have in 30 centimeters, like this. And then I can do a comparison between several plots and to estimate the yield that I'm going to expect. Okay, another example of plant height determining, this is from pepper plant. So I have days from planting. I'm just writing the date of planting. The farmer is measuring it once a week, and I can see if the rate looks good, if the rate is good enough. Is it too slow or too fast? If I have several plots from the same variety, I will show you it like this. Okay. Over here, I have another measurement of solar radiation, but we are running out of time, so I think it's understandable. The principle is understandable. I'm just measuring every week outside and inside the greenhouse, and then I calculate the percentage of penetration into the greenhouse, and then I can see that it reduces. So over here, I can tell the grower to clean the roof. Okay, but if I have several plots, I can do also average, and I can know for the other plot, for example, this is open flower per plant. I asked 20 growers from the same variety to count how many flowers, open flower per plant they have. And if I put it on a curve, I know that the average after 50 days need to be something like 2.5 flowers per plant. So I can tell a grower, if the grower calling me and he said that I have the impression that I don't have enough flowering. So, okay, so the question will be, when did you plant it? How many days from planting do we have? So he will say 50. So I will tell him, count how many flowers, open flower per plant you have. If he will say 1, I know that it's really low. And then I need to increase radiation or maybe to reduce fertilization. If he will tell I have 2.5, so I will tell you it's just your impression, but actually it's quite average. Okay, understandable? This is another example of measuring in many plots and having the results of calcium in the patios. Also, if I want to detect if grower is in the right place or not, so over here I have the average. And then we have the aspect of data organizing and communication for the grower, which is our last part. So if you have a sophisticated tools, this is tools that I use. I'm taking photos from the field from the same point. At 7 o'clock in the morning, you can ask the grower to do it for you. Just have the same photo from the same place, from the same point exactly, in 7 o'clock in the morning and in 12 o'clock in the noon. It's before transpiration and after transpiration. Sometimes you will see huge differences, like here, that you can see that the plant is wilting. That means that it's suffering. That means that irrigation is not properly very good. And even if it doesn't have all the equipment for tensiometers or other equipment in the soil, so still we can know that the irrigation over here is not good enough. And then we can just add enough water. And this is from far away. You're just calling the grower and telling him, just have photo in the morning and photo in the afternoon or in the noon. And just put it from exactly the same direction and the same frame, okay? Another thing that we can do if we have a time-lapse camera, this is company that I use. I used to do, so I have like time-lapse, so I can also analyze. First of all, I can detect the plant from far away for a period of time, and I can measure how is the development of the plant. And then I can even have a photo analysis. Okay, this is a company that gives this solution. It's I have to say it's my own one. It's a very small one, and we are giving this kind of service that the plant can develop, and I can detect and have it on the graph, and then I can see that there are some days of high growth comparing to other days that the plant didn't develop so much. And if I have also the temperature or the irrigation inputs, so I can know the reason why is it not growing properly. Okay, another thing is about the wilting. This is photos from the same day. You can see that in the noon time, when it's become 40 Celsius degrees in the greenhouse, and the relative humidity below 40, like here. So you see that the plant is wilting. And over here, I have it also on the graph when it started to wilt. Okay, this is wilting. So I can see that between 10 o'clock and 11 o'clock, there is a big wilting, and it stays until this time, which is until 2:30 approximately. And only then it becomes better. The reason that it becomes better is because I called to the grower and I told him to add another irrigation in this time. So the plant, instead of suffering, gets an available water that he can evaporate immediately. Now, how we can communicate with the grower, how we can communicate a very simple tool for data collection. I can tell you that what I'm doing with the farmers. Usually I will prepare a Google form, which is, it's free of charge, it's easy. And then you have a place that you can collect the data. And I will have just like a questionnaire for the grower, which is the plot name. What is the plot name? What is the height of the plant? How many internode per stem? How many flowers are open? If you are measuring for 10 plants, what is the average opening flower per day? Okay, per a particular day. How many fruit sets do you have? If I'm telling him to just collect the data from the soil extractor, what was the nitrogen level, what was the salinity in the soil, it just edit on the software. It's really simple. You can do it from your cellular device, and then you just have the data in front of you as a graph. Okay, you have like one place that you collect all the data from all of the grower, and it's really easy to manage. And then the recommendation and then follow up. So there is several options. There is the very simple one, the free tools, which I really encouraging you to use. I'm using it a lot. You can just share a calendar together with the growers, and just to put action items on his calendar, on the grower's calendar, and the grower can also give you a feedback if he did it or not. Okay, Another tool that I use a lot is just through WhatsApp. You know, sometimes the grower can just record the data, or you can just film. I'm just taking the photo of the graph and send it over to the growers. Okay, so this is something that I'm really encouraging you to starting from before investments, before you are starting to work with a system that you need to pay for, and you need to study, and to be really, you know, you need to be focused on working with the grower, and to do it together with him, to make sure that you are on the same page. The other options, we have plenty of options. You know, Israel, over here, I just brought an Israeli companies. We have plenty of them, a lot of companies, and a lot of platforms. And these platforms are for data collections. We have Mana, we have Fitech, we have Supplant, we have many alternatives. Ion Crop is the company with the image analysis of the plants. And then you can just have a communication, each one of them enabling you to have the data collection, but also to react and to just tell the grower to supply remarks and feedback on what you see as a consultant or as a extension service. Okay, so far I finished the slides, and now if someone have a particular question, I will be more than happy to answer.
Okay, thank you very much, Gilad. Now we have like 15 minutes of Q&A.
Yes.
I have two questions here.
Yes.
Answer the question, where is it? One of them. Thanks for interesting presentation. Is it clear? It is clear we can do a lot remotely, but mostly monitoring abiotic factors, including crop nutrition. Now is the question. What about insect pest and disease control?
Very good. Yes, very good question. Thank you for asking it. This is another thing that, you know, in Israel or in other places that we have a lot of agricultural activity in the same place, sometimes you can just take one person like a scouter, and he can do the scouting. But I think this is something that also grower can do by himself together with his consultant. For example, you can just prepare a file which is containing the name of the insects or diseases. Okay, if you don't know if the grower doesn't know how to recognize it by himself, he can just send a WhatsApp with a picture to the consultant and just ask what it is. And then you can tell him, if we have 5, like you are going to map the area and to tell him where should he visit, like in 10 different points on the farm. Okay, and over there you call it station number 1, number 2, number 3, and so on. And then you just need to, every station is like, you need to look at 3 plants from the bottom to the top. Okay, and then you just tell him numbers. How many aphids did you count? If it's only 1, so let's just have a flag on it, and let's see how it develops to next week. If you, for example, if it's a spider mite, you can tell him, if you are counting more than 3 on the same leaf, that means that this is the right time for treating it. Okay, this is the simple and the free tools. The other elements that we have, you know, in Israel, we have a lot of companies that are doing this detection from far away. But I have to be honest and to say that most of them are suitable for outside field, for an open field, and they're doing it from satellites, from drones, and from far away. And this is something that I think you can get to the information in the software, but I'm not sure it's a must right now. I think if we are talking about greenhouses, or if we are talking about simple tools that the farmer can apply from now, I would use the free and the original one, like I mentioned. Just take a map, mark stations, explain the grower what you want to see, and you can say that every suspicious thing, just take a photo and send it to me. By the way, I have to tell you that there is a lot of apps in the app stores that you can just have a photo of disease appearance or an insect, and it will recognize it almost. Some of them are working quite well. One of them is also very famous. It's Google Glass. Simple Google Glass, that you can just photo things and it tells you what you see. So most of the plant disease and insects are inside it. So you can just use that and just guide the farmer how to be its own scouter.
Okay, Gilad, there's another question.
Yes, please.
How can climate change affect our monitoring pattern and their accuracy?
How can
How can climate change affect our monitoring pattern and their accuracy?
I think I got the question right, but I'm asking from the person that asked it. If I'm not answering the right thing, so let me know, because I think it feels like a question with someone from hands-on, someone that know what he wants to ask. If I understood correctly, I mean, if it's cold weather, of course, temperature we need to detect all the time, all the relevant parameters that are mentioned in this slide are relevant all the time. But I can tell you from my own experience, for example, if we are talking about climate that become cool, okay, like in the Arava area in Israel on pepper. So we know that after the field suffers low temperature below 14 Celsius degree at night, I wouldn't find any new fruit setting. So in this period of time, the climate has changed. So I stop monitoring the fruit setting until the time that I'm going to have potentially a new fruit setting. Okay, did I answer it properly, or you meant something else?
Yeah, I think so. There's no response from the guy, but I think you answered properly.
Thank
Any
you.
other questions before we end the session? Like I said, you can use the chat button on the bottom screen. Okay, Gilad, I think that's it.
Wow. Okay. For me it was very fast. I hope you enjoyed the meeting. I'm looking forward to another meetings, and please participate on it. If you have questions and some topics that you want to have, so please tell Yuval. Please let him know. We can prepare anything that is interesting for you. Thank you for listening. It was a pleasure for me, and it's an honor for me that you are listening in this field.
Okay, Gilad, thank you very much. Gilad, it was a very interesting presentation.
Thank you.
Thank you, folks, for joining us today. We hope to see you again on a future lecture. We welcome you to watch our recorded lectures and to invite your friends and colleagues to watch them too. MATC, Mashav Agriculture Training Center, encourages you to invite your friends and colleagues to join our upcoming webinars. You can find more details about this on our website, Twitter, Instagram, and on our Facebook. Thanks, everybody, and see you next time.
Thank you. Goodbye. I wish I could meet everyone, but
Next time.
Next time.
bye.